Example 2. According to a study done last year, the average monthly expenses per cell phone loads of high school students in Manila was 350 pesos. A statistics student believes that this amount has increased since January this year. Is there a reason to believe that this amount has really increased if a random sample of 60 students has an average monthly expenses for cell phone loads of 380 pesos? Use alpha 0.05 level of significance. Assume that the population standard deviation is 77 pesos. Step 1. State the null and alternative hypothesis. Since it is claimed that the cell phone loads of high school students in Manila was 350, our null hypothesis is population mean is equal to 350. Then, is there a reason to believe that this amount has really increased if random sample of 60 students has an average monthly expenses for cell phone loads of 380? From the word increase, we use greater than for our alternative hypothesis. So, population mean is greater than 350. Step 2. Find the level of significance. Since on the given problem, the level of significance is 0.05, so we have alpha is equal to 0.05. For step 3, compute the test statistic. Since the variance is known and the given sample size is greater than or equal to 30, we use the c-test. And the formula for c-test is sample mean minus population mean over population is standard deviation over square root of sample size. And the given problem, so the sample mean, give random sample of 60 students has an average monthly expenses for cell phone loads of 380. So 380 is from the sample of 60 students. So the sample mean is 380. Then, our population mean, the average monthly expenses for cell phone loads of high school students in Manila was 350. So that is our population mean. And for the population SD, we have 77. Then, the sample size, we have 60. So we have over square root of 60. So after identifying all the given, we're going to substitute to the given formula. 380 minus 350 over 77 divided by 60. Our C value is 3.02. Step 4. Find the P value. First, we're going to draw a curve. Since in our alternative hypothesis, we use greater than, it means that it is one-tailed test and it is located to the right part of the curve. So, then next is we're going to look at the computed C value. The computed C value is 3.02. Let us use our table for cumulative binomial probability. Then find the row C. First is look at the first two digits of the Z value. So the first two digits is 3.0. Then find the column with a heading 0.02. So the value is 0.0013. Since it is one-tailed test, our p-value is 0.0013. And for step 5, draw a conclusion. Since p-value 0.0013 is less than 0.05, reject the null hypothesis. That is, the average monthly expenses for cell phone loads of high school students in Manila is more than 350 pesos. This result is considered to be significant at alpha is equal to 0.05 level, or since 0.013 is less than 0.05, there is a significant difference between the sample mean and the population mean. Example 3. The head of math department announced that the mean score of grade 9 students in the first periodic examination in mathematics was 89 and the standard deviation was 12. One student who believed that the mean score was less than this randomly selected 34 students and computed their mean score to obtain a mean score of 85. At 0.01 level of significance, test the student's belief. So first we're going to state the null and alternative hypothesis. Okay, our alternative hypothesis is population mean is equal to 89. Then, for our alternative hypothesis, one student who believed that the mean score was less than. So we're going to use the symbol less than 89. For step 2, we're going to find the level of significance. Since the given significance on the problem is 0.01, so we have alpha is equal to 0.01. Step 3. Test a statistic. Since the variance is known and the sample size is greater than or equal to 30, we're going to use the c-test. So, sample mean minus population mean over population standard deviation over square root of sample size. Our population mean is 89 and our sample mean is equal to 85. From randomly selected 34 students and computed their mean score to obtain 85. So that is our sample mean. And for the population standard deviation, we have 12. And we have 34 samples. So let us substitute to the given formula. 85 minus 89 over 12 divided by the square root of 34, we have negative 1.94. Step 4, find the p-value. So we're going to draw a curve, then let us look at the alternative hypothesis. So, since we use less than, our critical value is located on the left part of the curve. Then, let us look at the computed c-value. The computed c-value is negative 1.94. So let us use our table for cumulative binomial probability. First, find the row z and look at the first two digit. The first two digit is 1.9. And find the column with a heading 0.04. So the corresponding value is 0.0262. So our p-value is 0.0262. And for step 5, draw a conclusion. Since p-value 0.02 is greater than the level of significance 0.01, do not reject the null hypothesis. That is, the mean score of the students in the first periodic examination is not less than 89. This result is considered to be significant at alpha is equal to 0.01 level, or since 0.0262 is greater than 0.01, there is no significant difference between the population mean and the sample mean. In summary, hypothesis testing is a powerful tool that helps us make informed decisions based on data by following a structured process, stating hypothesis, selecting a significance level, analyzing data, and making conclusions. we can determine whether to accept or reject a claim with confidence, whether in science, business, or everyday problem solving. Hypothesis testing allow us to base on conclusion on evidence rather than assumption. Keep practicing, stay curious, and use data to make better decisions. Thank you for watching and see you in the next lesson.